restrict to move elliptical slot due to the motion of slotted link. If the link moves with constant speed, which means velocity x component is constant. Determine the magnitude of velocity and acceleration of pack A. We solve this one. Okay. So pack A, we need to find the position xy coordinate of A. At A, the velocity is tangent to the path. So the velocity direction should be like this. Then we can resolve the velocity into x and y component using detour. So x component is this, y component is this. Velocity x component is already given. That is constant. 10 meters per second. We need to find the velocity y component at A. An equation for this ellipse is given x squared over 4 plus y squared equals 1. And pack A, when x equals 1 meter, so A, when x equals 1, we plug in 1 into x, we solve for y, then we have positive, negative. Positive is for upper ellipse, whereas negative for down or lower ellipse. We solved the y already. That turns out to be 0.866 plus minus 0.866. So then pack A, we choose positive. X coordinate 1, y coordinate positive 0.866. If I ask you calculate the velocity, magnitude, and acceleration at pack B, then this is it. This is it. X component constant, in this case, y component should be positive. So then you have to use this one. Oh, P1, negative 0.866. Now the equation form for the ellipse, x squared plus divided by 4 plus y squared equals 1. That is called implicit function. We talked about implicit function the last time. Function format is like this. Constant. This is called implicit. Okay, then our function is x squared over 4 plus y squared, that equals 1. To find the velocity, we take a derivative of this function, implicit function, with respect to x. T embedded in x and embedded in y. So x is a function of x, function of time t, y also function of time t. Then we're going to use chain rule. And derivative of 1 with respect to time t equals obviously 0. Or then we're going to use what? First of all, we need to take a derivative of this guy with respect to x. And followed by dt over dx. Right? This is it. And second one, derivative with respect to y and dy over dt. And that is called the chain rule. So derivative of 104 x squared with respect to x. Then bring down power, lower power by 1. So it'll be what then? 1 over 2 x dx over dt, that is x dot, plus derivative y is with respect to y, that is 2y. dy over dt, that is y dot. That equals 0. X dot is v sub x, velocity x component. Y dot is velocity y component. Okay, and then using this equation, we can solve for Vy. Vx is constant. And at A, which means x equals 1 and y equals 0.866. We plug in x value, y value into this relationship and we solve for y dot. Okay, y dot, that is actually velocity y component. That's what we did the last time. We solve for y, rearrange this equation, solve for y. Solve for, sorry, velocity y component. That is negative x. X dot is v sub x divided by 4 times y. We multiply 2 on both sides. And then rearrange this one. Isolate. And then we solve for v sub y. And now then we plug in. X value, how much is 1? Y value 0.866, and v sub x is constant. V sub x is already given. V sub x right here. So evaluate. Turns out to be a negative. Negative, where is it? Negative 2.887 meters per second. So this is negative, means what? It's down. Okay, see, perfect, right? So this is 10, y component negative 2.887, because y component directed downward, that obviously that is negative. Then magnitude, of course we can find this angle too. As you see, x component, y component, and the magnitude of velocity formed a right triangle. You can find that angle. Opposite over adjacent. Arctangent of opposite over adjacent. Opposite is y component of velocity. X component of velocity is adjacent. So we can find an angle. So I can modify similar problem and put it in your test. All right. Now then, magnitude. Velocity at A. That is square root of velocity x component square plus velocity y component square. So you plug in velocity x component 10, velocity y component negative 2.887, make a square, add them, and take a square root of it. Okay, that turns out to be 10.4. What question you would have about this? Remember chain rule and also implicit function, derivative of implicit function. And we notice x is function of t. So t is embedded in. Y also function of t. So therefore we use chain rule. Does it make sense to everybody? Team, okay, good. Your thumb flies away, fly around on the screen. Awesome. All right, and what about acceleration? Acceleration is the derivative of velocity. By taking derivative, we had this relationship. we take one more derivative with respect to time t. Okay, let me delete. Everybody got this thing down? Okay, I need to make some space. Oh, okay, the one more tip. One more tip. Of course, you can solve for y. You can solve for y. Right? You can solve for y. So x squared divided by 4 plus y squared equals 1. Then y squared equals, what is it? 1 minus x squared over 4. Then y equals plus minus square root of 1 minus x squared over 4. Positive is 4, this one. Negative is 4, or lower ellipse. Okay, then that is what then? 1 minus 104 x squared power is 1 over 2. Now then, you take a derivative with respect to time t. Then first of all, this function itself is a function of x. You take a derivative with respect to x. Again, we use a chain rule. Then as you see that, parentheses, we have 1 minus 1 over 4 x squared over power 1 over 2. So we take derivative, bring down power, lower power by 1, 1 over 2 minus 1. And I don't know for sure if you still remember, derivative of function, that is derivative of outside inside. Outside is function is this, the power is half. So we apply power rule. Inside, still we have function 1 minus 1 over 4 x squared. We take a derivative of this with respect to x. Then derivative 1 is 0. Derivative 1 over 4 x squared is negative 1 over 4. Bring down power, lower power by 1. So this is the derivative of this function with respect to x. Then chain rule, dx dt. So kind of a little bit complicated. Of course, first derivative we can do it, and next one we can take one more derivative. That would be a little more complicated. That's why I use implicit function derivative instead of explicit function derivative. This is reason. Okay, this is kind of tip. If this function is simple enough, then you can take a derivative and using chain rule again. But in this case, because we have quadratic, this is quadratic, sort of quadratic. That's why taking derivative using explicit function form is kind of difficult. But doable, obviously can do it. You can do it, but a little bit complicated. That is my tip. All right. Well, anyways, we're going to keep this one, and then we take one more derivative. We're going to keep using implicit function format for the derivative. Okay, you forgot implicit, explicit function, derivative. You need to go back to calculus and restudy. So the velocity, we found it. Now then, acceleration. Okay, we use that one. Okay, 1 over 2 x times x dot plus 2 times y dot. Take one more derivative. derivative of 1 over 2 x dot plus 2y y dot, that equals 0. Derivative of 0 is obviously 0. Okay, then this is basically what? Product of two function. Product of two function derivative. I told you already, right? Suppose we have a function f and g, then dy with respect to t or x doesn't make any difference. First function derivative followed by second function itself plus first function itself and derivative of second function. That is the rule for the derivative of product of two functions. Okay, now then 1 over 2 is constant. First function is x. Derivative of x with respect to t is x dot. Followed by second function itself. Plus 1 over 2. First function itself, x. Second function derivative is x2 dot. Plus first function 2 is just coefficient. First function y, derivative y is y dot, followed by second function itself, plus 2 times first function itself, and then derivative of a second function, that is y2 dot. That equals 0. Okay, then summarize it. 1 over 2 is constant. Common, x dot times x dot, that is x dot square. And next, x and x2 dot. x2 dot is actually acceleration x component. Oh, by the way, x dot is velocity x component. Plus 2 times y dot is a velocity y component. So y dot square, there is a velocity y component square, plus y and y2 dot. y2 dot acceleration y component. That equals 0. Now then I'm going to replace x dot by Vx. All right, this is it. Now then we solve for, see, velocity x component was constant. That was given already 10. Take a derivative. Then a sub x is the derivative of 10 with respect to time t. That is obviously 0. Oop, 0. Okay, then a sub x is 0, right? A sub x is 0. Now, v sub x is given 10. So 1 over 2, 10 square plus 2 times vy square plus 2 times y ay. That equals 0. By taking first derivative, we already solved for. Now then at a, Vx still 10. Oh, we don't have a Vx, so it's okay. We don't need it this one anymore. But the Vy we already calculated. That was a negative 2.88. and y value was 0.866. Then now they're using this one. You plug in this one there, and then we solve for ace y. We solve for ace y. Rearrange the formula, and then you solve for ace y. Okay, I'm going to skip that algebra. That turns out to be negative 80, negative 38.49 meters per second squared. Now then, let's graph this one at point A. At point A, acceleration x component is 0, y component is negative. So y components, this is it. Y component, this is it. A sub x, because a sub x is 0. Ay equals to negative 38. Now the magnitude A equals the square root of ax squared plus ay squared. Then a sub x is 0, plug in a sub y, that is negative 38, make a square, that is positive and take a square root of it, and turns out to be 38.49, and round up, keep up to 3 significant figures. So 38.5. Okay. So summarize it. We started off implicit function format, take a derivative to get the relationship between x computed velocity, y computed velocity. This is it. And take another derivative to get this one. And then we solve for y component of acceleration and evaluate at A. Okay, then plug in. And we solve for magnitude of acceleration. All right. Is everybody good with that, or anybody have some specific questions? Okay, I need the feedback. Okay, you need to study, right? You need to restudy implicit function, derivative, and also chain rule, those things. And also derivative of function, actually product of two functions, this one. All right, let's move on. We finish up. Okay, curvilinear motion, normal and tangential components. That is 2D curvilinear motion. So particle is moving along any arbitrarily shaped curve like this. Then remember, always instead of x, y axes, we set up tangential axis and normal axis. So look at that. At any point, say at any point here. So this is any arbitrary shaped curve. At that point, that curve shapes like arc of a circle with the radius of rho. This rho is called radius curvature. Radius curvature is given here, this formula. So at this point, we need to evaluate radius curvature to find the radius of the circle using this formula. If curve is given as a function of x. Okay, now then, set up tangential axis. Tangent axis is always tangent to the path at the point. That point tangent to the path. Particle moving forward, so forward is positive. and normal axis to the center of the circle, because this path at the point shapes like arc of a circle with a radius of rho. So that this is normal axis to the center. To the center is positive. Then outward is negative. Okay? Keep that in mind. Then tangential acceleration along the tangent to the path. This is tangential acceleration, AT. Normal acceleration to the center, A sub n. Tangential acceleration is simply derivative of position with respect to time t. This is it. Whereas a normal acceleration, I want to remember this formula. Normal acceleration at this point equals tangential velocity, that point squared divided by radius of curvature, and radius curvature can be calculated using this formula, and evaluate radius curvature at this point. Okay, then total acceleration. This is total acceleration. Is the square root of, okay, this is it, for example. All right, tangential acceleration plus normal acceleration will give total acceleration. So tangential acceleration plus normal acceleration, that is a vector sum, and three of them will make a right triangle. So that this guy, translate this guy to here. So this is same as normal acceleration. Then as you see that tangential acceleration, normal acceleration, total acceleration formed a right triangle. Then you can find this angle. And how you can find this angle? Angle theta equals arctangent of, in this case, opposite over adjacent. Opposite is a sub n over adjacent a sub t magnitude. Once you find this angle, then I always ask the angle for the total acceleration from the horizontal, from here. Play with the geometry. You should be able to find the angle for total acceleration counterclockwise from the horizontal. Common mistakes, you give simply the angle, this one. That is the angle between tangential and total acceleration. I ask angle, let me use a different one. Okay, so let's do this one. This is AT. Normal acceleration is this. And total acceleration is this. I'm going to ask you find an angle for total acceleration counterclockwise from the horizontal. This is horizontal. I want to find this angle. Or if particle move backward, then this is tangential acceleration. This is normal acceleration. Then total acceleration is this. Okay, this is total. Then you need to find an angle for total acceleration from the horizontal. This angle, counterclockwise. What is it? I'm going to ask you, okay, in your actual test. Find that angle. All right, well, anyways, let's work on this problem. The van travels over the hill. That is curving linear motion again, described by y equals negative 1.5 times 10 to negative 3 x squared plus 15 feet. If it has constant speed, of 75 feet per second. That means, that is constant speed means tangential velocity is constant. Determine the magnitude of Vance acceleration when x equals 50. When x equals 50 is here. When x equals 50, then this point, at this point, what is velocity? That point, we need to set up, because this van travels up a hill, so then tangential axis is this, up the hill, and the normal axis is this. Now then, when x equals 50, that point, the curve shapes like arc of radius, circle of radius rho. This is center. Okay. Determine the magnitude of Vance acceleration. Okay then. Ace of t, that is dv over dt. V sub t is given constant, so it'll be obviously 0. And also, a sub n equals tangential velocity square over radius curvature. Radius curvature you can determine using this formula. So y is given. Take a derivative y with respect to x, and plug in x equals 50. Then you can evaluate the dy over dx when x equals 50. And second, this is second derivative. Take one more derivative with respect to x, evaluate when x equals 50, then you should be able to calculate the radius curvature. Then you can calculate this one, right? But in your actual tests, you are not going to see constant tangential velocity. Instead, velocity would be a function of what? Then you need to evaluate the velocity at a certain point. Okay, so now then, if we draw acceleration when x equals to 50, tangential acceleration is 0. Normal acceleration is this. In this case, this is simple. Asn is the same as total acceleration. Okay, so I want to find this one, radius curvature, and calculate a sub n, and the total acceleration is the square root of at squared plus a sub n, because a sub t is 0. This is the same as a sub n. Okay, I want you to do that by yourself. Okay, let's do a group activity. So I'm gonna make breakout room. Oh, where is breakout room activity? Breakout. Oh, right here. So 13. So make a full group. Okay, what time is it now? So 2:36. We have plenty of time. I'll give you about what? 35 minutes. So you simply calculate the radius curvature and plug in that value into this formula, and v sub t is constant. So what? Then you can evaluate a sub n when x equals 50 feet. Okay, first group, George. Huh? Room 1, George? Room 2, George again? What is going
Oh,
on?
sorry. That's on my side. I think it's acting up. My computer's been acting up, hence the reason why I joined late. Just
Oh,
ignore the other George.
oh, okay, okay, okay. All right. So
Yeah,
what?
I tried to
Yeah.
sign on through my computer, my laptop, and now I'm signed on through my desktop because my computer was acting up.
Okay, okay, okay. So what the randomly? Okay, randomly I send you because the individual you can work this one or you talk to other people in your group.
Yeah, just send it to the lowercase George Vega instead of the capital.
Okay, lowercase. Okay, okay. All right. Then Georgia first group and then Jonathan. Okay, it's Michael. All right. Okay, randomly. Yeah. Okay. All right. Why don't you join in, assign the group and the work on this problem. Okay, because everybody came back. Okay, this is my workout. Y equals negative 1.5 times 10 to the negative 3x squared plus 15. Take a derivative with respect to x. So coefficient is negative 15 times 10 to the negative 3. And the derivative x squared is 2x. Now we need to evaluate this one when x equals 50. So plug in 50 into x. That turns out to be negative 0.15. Take one more derivative, then coefficient is the same, negative 1.5 times 10 to the negative 3. Derivative of 2x is x. Turns out to be negative 3 times 10 to the negative 3. But remember, radius curvature is distance. Distance should be positive. In this case, second derivative is negative. That's why we take absolute value right here. So plug in all these values and this one into the formula, and then rho turns out to be this. Anybody got this one right? Rho, radius curvature. Okay, good, very good. Okay then, normal acceleration formula. Tangential velocity squared divided by radius when x is 50 feet. Tangential velocity was constant, 75. Make it square divided by 344.65. So normal acceleration turns out to be then 16.32. Then total acceleration is same as normal acceleration because tangential acceleration is 0. Does it make sense to everybody? What if I ask you find the velocity x and y component using this curve?
So for that, for the d squared y and x squared, which one's on top, which one's on bottom, or is it like doesn't matter? I'm trying to,
Rho,
because I see
no,
what you're
no, no.
pointing at.
Look at that. Rho equals 1 plus dy over dx. That is the
Hmm.
first derivative square. And
Okay.
divide by second derivative of y respect x absolute value. So this value in the denominator
Mm.
and this value in the top.
Okay. Okay.
Then rho turns out to be 344.65 feet. You got it, George?
Yes, I do. My apologies.
Okay. And then we evaluate normal acceleration. So it turns out to be 16.32. Then total acceleration is the same as normal acceleration because tangential acceleration is 0. Because the tangential velocity was constant. But in your actual tests, tangential velocity, you need to find it is not actually 0 or function of some variable. Then for given variable, you need to evaluate tangential velocity. Okay, now, what if why is this? That is the equation for the path. Question. When x equals 50. This is rectangular coordinates instead of normal and tangential. So we can solve exactly the same problem two ways, using xy coordinate components or normal and tangential components. So if you ask solve for vx and vy using this function, and then previous problem, similar to previous problem, what is vx? dx over dt, isn't it? vy dy over dt. The function was given. So then see y is a function of x. Then take a derivative with respect to t then. Then you use chain rule, right? Chain rule, because the function itself is function of x. This way. Then this guy is what? The piece of y. This is f prime or x dot, and this is vx. This is a relation between y computed velocity and x computed velocity. Okay, let's do that then. See, y is given as a function of x. Then take a derivative, and that equals then dy over dx, dx over dt. Okay, take a derivative. What is it? Coefficient to negative 1.5 times 10 to negative 3. Derivative of x squared with respect to x is 2x. Now then dx over dt, that is a velocity x component we used to call x dot. Okay. So then y dot equals 2 times negative 1.5 and negative 3 times 10 to negative 3 x times x dot. Okay, now we evaluate when x equals 50. Okay, plug in then. Vy equals, plug in 50 into x. So 50 times, oh, did I miss something? Oh, wait a minute, yeah. Okay. That means something. Wait a minute. Okay, well, anyways, so what? X equals 50. Okay, 50 times -3. So -150 times 10 to -3. So it turns out to be then -0.15, and v sub x. This is a relationship between velocity x component and y component. And problem gave us what? Speed when x equal 50. So speed means what then? Square root of this is it. Now, so the speed is 75. 75 equals velocity x component. Velocity y component is this. Make a square. Then we have only one variable. We solve for Vx, whatever number comes out. And then relationship between Vx and Vy is this. Then plug in Vx value into there. We solve for Vy, right? But we notice that if Vx is positive, then Vy is negative, and vice versa. But when x is 50, halfway between here, then tangential velocity tangent to the path. This is it, because this fan climbs up. So then x component gotta be negative to the left. Y component is positive. So that then we can choose velocity x as negative and velocity y obviously positive. So what? By taking derivative, we simply find the relationship between the velocity y component and the velocity x component. And graphically, we found that the velocity x component should be negative, whereas velocity y component should be positive. So we choose right sign for velocity x and y component. And also we can find this angle too. That makes sense? And after that, using this relationship, we can take one more derivative with respect to time t. Then we can find the relationship between acceleration, x component, y component. Okay, this is kind of a tip for you. All right, this is it. I want you to take a test next week by next Saturday. Testing center, Oak Ridge and the Harriman Testing Center will be open Saturday too. So I want to check their hours. You can find their hours from webpage, Rose State Community College webpage. Go visit and search. You type simply testing center. Then there are several menus. You can click hours, and then you can find their hours.
So what's the answer for Vy? You left it blank after you put Vx equals 0 and explained all that.
I gave you an idea. I did not calculate. 75,
okay.
75 equals square root of Vx squared plus negative 0.15 Vx squared. Then you have only one variable Vx. You solve for Vx, right?
Okay.
And then using that relationship, Vy equals negative 0.15. Then once you find Vx value, then you can find the Vy value. But graphically, Vx should be negative and Vy should be positive, right? That makes sense?
Yes, makes sense. Thank you.
All right, yeah. And take one more derivative on this relationship, then you can find the acceleration, x component, y component. All right. Okay, so this is it. All right, have a good weekend. So remember that Tuesday we're gonna begin new chapter 13. I already uploaded the most recent version of lecture notes into momentum. All right, have a good weekend. See you Tuesday. Good luck.